Are you tired of seeing ads on websites, apps, TVs, or even your smart fridge? Frustrated with browser extensions and tools that never fully block them? This is Pi-hole, a network-wide ad blocker running on a Raspberry Pi, and it blocks ads on all my devices. It also blocks tracking services and malicious domains, and it's all free, open source, and legal. In this video, I'll walk through how I set up Pi-hole on a $15 Raspberry Pi. Later in the video, I'll add Tailscale to my setup, which lets me use Pi-hole securely from anywhere, even off my home Wi-Fi. And finally, I'll set up Unbound, so we don't have to rely on third-party DNS providers, giving us more privacy and control over our data. Here's all you'll need to get started. The main component is the Raspberry Pi 02W. You can use other Raspberry Pi models, but the Pi 02W is a cheap, lightweight, and low-power option. You'll also need a microSD card, a microSD card adapter, and a micro USB cable for power. You can find links to all the components down in the description. Once we have all the components ready, we can move on to the installation. First, we need to flash Raspberry Pi OS onto our microSD card. I'll plug the microSD card onto my computer, then download and install it by Imager from the Raspberry Pi websites. Once the installation completes, I'll launch the Imager. Here, we're prompted to select our device. I'll go with the Pi 02W, but if you're using a different Raspberry Pi model, just select the one you're using. Next, we're prompted to choose an operating system. Under Other, I'll select Raspberry Pi OS Lite's 64 bits. Since Pi-hole runs entirely in the background, we don't need a desktop environment, and this keeps everything lightweight and efficient. On the next screen, we'll choose our microSD card that we want to flash and continue. After that, we're asked to assign a custom hostname, and I'll name mine Pi-hole. This will help us identify the device on the network and let us connect to it over SSH using the hostname instead of an IP address. Then we move on to localization settings. I'll select my location and time zone and hit next. Here, we're prompted to set up our credentials. I'll enter a username and password, which we'll use to SSH into the Pi later. After that, we can configure our Wi-Fi credentials so the Pi can connect to our network. Finally, we'll want to enable SSH so we can manage the Pi remotely. We don't need Raspberry Pi Connect for the setup, so we can leave that disabled. With everything configured, I'll click Write and confirm the pop-up window. This process takes a few minutes, so I'll fast forward here. Once it's done, we can click Finish. At this point, our microSD card is fully flashed with Raspberry Pi OS. Now we can insert the microSD card into the Raspberry Pi, power it on, and give it a minute or two to boot up. We can now open a terminal window and SSH into the Pi using the hostname, username, and password we configured earlier. Before installing Pi-hole, it's a good idea to update the system packages. First, I'll run sudo apt update to refresh the package list. Then I'll run sudo apt full upgrade to install any available updates. I'll confirm the prompts and wait for the updates to complete. Once that's finished, I'll reboot the Pi to allow all changes to take effect. After it comes back online, I'll SSH back into it. Next, I'll head over to the Pi-hole documentation, which will be linked in the description, and copy the installation command. I'll paste that into the terminal window and start the installer. During the installation, we'll be guided through a series of configuration screens. For the first few prompts, we can just confirm and continue. Next, it's asking us to set a static IP address for the Raspberry Pi. This is required because Pi-hole needs a consistent IP address in order to function reliably as a DNS server. Now, how you do this depends on your router. In my case, I'm using TP-Link Deco, so I'll configure this using the Deco app on my phone. However, the steps will be similar for most routers. In the Deco app, I'll go to Advanced Settings, then Address Reservation. From there, I'll select my Pi-hole device from the list of connected clients and save it. This ensures my Raspberry Pi always gets the same IP address on the network. With that done, we can return to our installation and select Continue. Now we're asked to choose an upstream DNS provider. There are several options here, but I'll select Cloudflare since it's a popular, fast, and reliable option. Later in the video, we'll replace this with a custom DNS resolver using Unbound. After that, Pi-hole asks about block lists. I'll select Yes to include the default Stephen Black's host list. This is a solid starting point, but we'll add more block lists later for even better coverage. Next, we can enable query logging and choose a privacy option. You can choose this based on your own preferences, but I'll go with hide domains and clients. At this point, the installer will continue and finish setting up Pi-hole. Once it's complete, it shows us the admin dashboard URL and the default login password. Before moving on, I'm going to change the default password. I'll run sudo pi-hole set password and enter my new password. Now, Pi-hole is fully installed and we can access the admin interface from our browser. This is the Pi-hole dashboard. As you can see, there aren't any queries coming in yet, and that's because I still need to configure my network to use the Pi-hole as its DNS server. To do that, I'll go back to the Deco app. Under Internet Settings, I'll open DNS address and set a manual DNS. I'll paste in the IP address of my Raspberry Pi and set it as the primary DNS. In my case, this throws an error, so instead I need to configure it under the DHCP settings. I'll paste the Pi-hole IP address as the primary DNS server there and save the changes. Now, when we head back to the Pi-hole dashboard and refresh, we can see queries starting to come in. Here, I'm seeing an error under the domains and lists section, even though domains are already being blocked. To fix this, I'll go back to the terminal and run sudo pi-hole update gravity. This refreshes the block list and reloads the DNS service. After refreshing the dashboard, we can see the updated domain count, around 80,000 domains from the default list. To take Pi-hole even further, we can add additional block lists. There's a well-maintained GitHub repo that curates block lists for different use cases, which I'll link in the description. Here, I'll choose the multi-pro list, which is recommended by the maintainers and offers a good balance between blocking and privacy protection, but you can choose one based on your preferences. I'll copy the add block style URL, and back into the Pi-hole admin panel under list group management, I'll paste the URL. I'll also copy the name of the list and add it as a comment for reference, and then click add block list. Then I'll run the update gravity command once again to fetch the new list and reload the DNS server. I won't go too deep here, but you can also add allow lists, block specific domains, or even use regex filters depending on your needs. And with that, Pi-hole is fully installed and running on our Raspberry Pi. Before moving on, it's helpful to get familiar with the Pi-hole CLI. You can run pi-hole-h to see all available commands or check out the official documentation. From here, we can check the Pi-hole status, view logs, and update Pi-hole easily, which will be useful for maintaining our Pi-hole setup. To confirm that Pi-hole is working, we can visit a website like the Octa speed test and see that ads are no longer appearing. For comparison, this is what the same page looks like without Pi-hole enabled. We can also see the effect on my iPhone. When I load the daily Wordle, the ads don't load and I can enjoy Wordle without distractions. At this point, Pi-hole is blocking ads, trackers, and malicious domains for every device on our home network. But I want to take this one step further and have Pi-hole act as my DNS server even when I'm not at home. To do that, we're going to set up Tailscale. Tailscale is a free mesh VPN that creates a private, secure network between your devices. It allows you to access your home network and things like your Pi-hole from anywhere, without port forwarding or complex firewall rules. To get started, we'll head over to the Tailscale website and create an account. I'm signing in with my Google account, but you can use any of the available options. Once logged in, we can see our Tailscale dashboard. Right now, it's empty because we haven't added any devices yet. Let's start by installing Tailscale on our Raspberry Pi, which is running Pi-hole. I'll head over to the Tailscale documentation, scroll down to the Raspberry Pi section, and copy the install command. Back in the SSH terminal, I'll paste and run that command. After the installation completes, we can bring Tailscale online by running sudo tailscale up. This will prompt us to authenticate in the browser. Once we log in, the Raspberry Pi shows up in the Tailscale dashboard, meaning Pi-hole is now connected to our private network. Next, we need to configure Tailscale to use Pi-hole as its DNS server. From the Tailscale dashboard, I'll copy the IP address of the Raspberry Pi and head to the DNS tab. Under Name Servers, I'll click Add Name Server and paste in the Pi-hole IP address. I'll also enable the option to override DNS servers. Now, we need one quick change inside the Pi-hole admin dashboard. Head over to the DNS settings and enable expert mode. Here, under Interface Settings, select Permit All Origins. This allows DNS requests coming from Tailscale to reach Pi-hole. This is safe to do because access is restricted to devices authenticated on your private Tailscale network and not to the public internet. At this point, Pi-hole is officially acting as a DNS server for Tailscale. Now we can add our other devices. I'll first install Tailscale on my Mac, and following the setup wizard, I'll allow the required permissions and connect it to my Tailscale accounts. Once connected, my Mac appears in the dashboard. That means even when I'm away from home, DNS requests from my Mac are routed through Pi-hole, and so ads are still being blocked. I'll do the same on my iPhone by installing Tailscale from the App Store. Here, I'll log into my Tailscale account to connect it to my network. With this setup, I get Pi-hole's ad blocking capabilities everywhere I go, not just on my home Wi-Fi. Next, we're going to be setting up Unbound. When we first installed Pi-hole, we chose Cloudflare as our upstream DNS provider. That means every DNS query that isn't blocked by Pi-hole gets forwarded to Cloudflare. And even though Cloudflare is fast and reliable, I don't want a third-party DNS provider seeing all of my DNS requests. To fix that, we're going to add Unbound to our setup. Unbound is a recursive DNS resolver, which means instead of forwarding queries to an external DNS provider, it resolves them itself by directly querying authoritative name servers. This removes the need for a third-party DNS provider and keeps DNS resolution entirely within our local setup. Now that we understand why Unbound is useful, let's set it up on our Raspberry Pi. First, I'll head over to the Pi-hole documentation and open the Unbound guide. Scrolling down to the installation section, I'll copy the install command and run it in my SSH session. Once the installation completes, we need to create a configuration file for Unbound. The configuration in the documentation is a good starting point, so I'll copy the file name and create it using nano. Then I'll copy the configuration and paste it in the file. Here, I'll make a small change. I'm setting do IP6 to no since I'm not using IPv6 on my network. After that, I'll save the file and exit nano. Then, we'll restart the Unbound service to apply the new configuration. The final step is telling Pi-hole to use Unbound as its upstream DNS provider. I'll head back to the Pi-hole dashboard, go to Settings, DNS, and under Custom DNS Servers, paste in the Unbound address. Then, I'll save the changes. To confirm that Pi-hole is using Unbound for DNS resolution, we can run a dig command. The response shows that the DNS query was successful with a no error status. We can also check the Pi-hole query log to verify that the request was resolved from our Unbound server address. At this point, Pi-hole is blocking ads and resolving DNS queries locally without relying on a third-party DNS service. And that's pretty much it. I now have ad blocking across all of my devices even when I'm away from my home network. Looking through the dashboard, thousands of DNS queries are being blocked daily, more than a quarter of all DNS traffic. One thing to keep in mind is that Pi-hole can't block ads on some platforms like YouTube because those ads are served from the same domains as the actual content. If you found this useful, feel free to leave a like and subscribe for more videos like this. Thanks for watching, and I'll see you in the next one.